This is number 40 from chapter 6, section 2 from the back of your book. It reads, it takes 585 joules of energy to raise the temperature of 125.6 grams of mercury from 20.0 degrees Celsius to 53.5 degrees Celsius. Calculate the specific heat capacity and the molar mass capacity of mercury. So the first thing we want to do is understand we have Q, M, delta T, and we're looking for S. So we're using this equation as a base. Right now we're trying to solve for S, so I'll get delta T and M out of there by dividing both sides by M delta T. Those will cancel, so I will have Q over M delta T. What this allows me to do is simply plug in all these values that the question just gave me and chug. Let's see, mass 125.6 grams. And then the temperature change, let's see, 53. Well, I'm just going to do this on the calculator. No need to make some silly mistake. 53.5 minus 20. 33.5, that was pretty silly. I should have been able to do that in my head. So 33.5. That's going to be degrees Celsius. Now notice when I do this calculation, I'll have the units of joules over grams per degree Celsius, which are the units for specific heat capacity. So I know I'm on the right track. All that's left to do is do this calculation. 125.6 times 32.5. Let's see. All right, and my calculator tells me .13903. Now, significant figures. Let's see, you got 3, 4, 3. So I'm going to use 3. So I'm going to round right there. So 0.139 joules per gram degree Celsius equals S. Slam dunk. All right. Awesome. All right, the question, we're not done with the question though, is molar heat capacity. Molar heat capacity. So what we're looking for here is something that will tell us how much energy it takes to raise the temperature of 1 mole of a substance by 1 degree Celsius. This is a molar heat capacity. I'm looking to generate a number with these units. Now, I have all of this stuff. Okay, I have all of this stuff already. I have the specific heat capacity. So if I multiply those two terms, or that is grams per degree Celsius, when I do that, grams will cancel. Grams are going to get out of there, so as a result, I will have, multiply by the, I messed that up. By the molar mass of Hg. A little bit of an oversight on my part. Should have made sense while I was trying to talk about it. I'm going to take this. I'm sorry. You know what I'm talking about. I've messed this up way too much. Okay. Start with specific heat capacity. All right. We know what that is. 0.139 joules per gram degree Celsius. Now, if I multiply this by the molar mass of mercury, you might be wondering, why am I doing this for mercury? Question says of mercury. Okay, this stuff is mercury. This is a mercury sample. Take the specific heat, multiply that by the molar mass of mercury. Now, like it was supposed to earlier, these grams will cancel right there. And so we'll end up with a unit of joules, okay, nothing's happened to the joules, over, nothing's happened to the degrees Celsius, nothing's happened to the moles, so moles times degrees Celsius. And this will be the molar heat capacity, the heat that's required to raise 1 mole of a substance by 1 degree Celsius. And the only calculation I have to do in order to find this is multiply the specific heat capacity by 200.6. Now my calculator tells me 27.89. We got 3 significant figures, 4 significant figures, so I'm going to keep it to 3 significant figures. I'll round it to this 8, so I'll do 27.9. Alright, so we have the specific heat capacity of mercury and the molar heat capacity for mercury.